At first, take my salam, my honorable chairs. Today, I am going to representing our research work. Paper ID is 1502 and title is Hybrid Deep Learning for Lychee Leaf Analysis, Health Monitoring and Growth Stage Detection. And I am presenter. My name is Vishya Dash. This is our outline of our today's presentation, and I will explain one by one. Let's start. Introduction. Lychee. Lychee is a high-value tropical fruit widely cultivated in Bangladesh, India, and China. Its productivity is highly dependent on proper monitoring of leaf health and growth stages, which directly influence flowering, fruit quality, and yields. So, we can see that the lychee has the economical, nutritional, and medicinal value in our country. Traditional monitoring relies on manual visual inspection and technological scale, which are time-consuming, error-prone, labor-intensive, etc. Convolutional neural network can automatically learn features from image, aiding accurate classification. Problem statement. Traditional manual inspection methods struggle to accurately identify and categorize lychee leaf health and growth stages. There is a need for more efficient and reliable approach to classify lychee leaf to detect which action is needed to take action for better production. The lack of well-structured dataset and comparative hybrid model poses a significant challenge to achieving high model adaptability and precision agriculture. Related work. Here we can see that the previous researcher they only use machine learning or single CNN deep learning, and they got very simple and very less accuracy. And here we can see that our proposed CBT hybrid model that gain very impressive accuracy. That is the 99.74%. Objective. Our objective is that firstly collect a dataset and pre-process of lychee leaf images, train and fine-tune multiple deep learning models like ResNet 1-to-1, Inception B3, and MobileNet P1 on our proposed dataset. Evaluate the performance of these models using metrics such as accuracy, precision, recall, F1 score, etc. Identify the best performing model to build our proposed hybrid model. Outcome and impacts. Key result, the best performing model, our proposed CBT hybrid model that gained 99.74%, that demonstrate the effectiveness of our proposed model. Impact, the research contribute to the precision agriculture by providing an automated method for classification of lychee health and growth stages. The study highlight the importance of collaboration between AI researcher and farmer to improve crop production. Methodology, this is the proposed methodology workflow. Here we can see that this is the our primary data set collection, and here have the 5 classes, and this is the pre-processing technique, and we split the data set 70% for train, 15% for validation, and 15% for test. And we train the 3 baseline model, ResNet 1-to-1, Inception B3, Mobile Net B1, and we build the proposed model, and we also done the evaluation study, and after all we measure the and analysis about our model's performance. Dataset. We are there are 2582 high resolution image having in our dataset with 5 classes pre-process. At first we manually pre-process resizing and eliminate some images that is the very noisy and the blurry and very darkness, and then we apply some advanced pre-processing technique like Clahi normalization, brightness adjust to improve contrast, detail visibility, and noise reduction. These steps collectively normalize illumination and highlight key leaf structure that is very effective and for our image model. And here this is the figure to visualize the pre-processed image. Experimental result. Here is the confusion matrix of baseline 3 models. This is the confusion matrix illustration, and here we can see that the ResNet 1-to-1 can detect 378 sample out of 406, and Inception B3 that it can detect 394 sample out of 406, and another one MobileNet B1 that detect 401 out of 406 sample. And this is the uh, performance of ResNet 1-to-1. This figure here is the train and loss accuracy, and this is the performance wizard, and this the table shows the class-wise performance metrics of ResNet 1-to-1. Here we can see that the ResNet 1-to-1 that gained 93.10% and error rate is 6.90, and precision recall F1 score respectively show here. And the performance metrics performance of Inception B3. This is the loss and accuracy curve. And this is also a table that shows the class-wise performance metrics of inception b3 and performance inception b3 that gain the 97.04% and error rate is 2.96% and precision recall effort score respectively show here. And lastly, the last baseline model, that is the MobileNet B1, that getting 98.28% accuracy. And this table shows the class-wise performance and the loss and validation accuracy curve is also shown here. The comparison of baseline 3 deep learning model. Here, we can see that the best performing model is MobileNet B1. That's why we pick the MobileNet B1 for building our hybrid model. Let's see about how our proposed model is better than the baseline CNN model. This is the confusion matrix of our proposed CBT hybrid model. Here we can see that the it can detect sample 405 sample out of 406. It misclassify only one, and its confusion made only between the right and sentence leaf. And here it is the loss and validation accuracy curve. Here you can see that the train and validation gap is very tiny, and it shows this our proposed model is very generalized, and this its gain the accuracy very impressive, that is the 99.74%, and error rate is very small, that is 0.28. Precision is 99.80, recall 99.80, and F1 score 99.60. And this table also show the class-wise performance of our proposed CBT hybrid model. Conclusion: the study demonstrated the effectiveness of deep learning, particularly our CBT hybrid model that gained the very impressive accuracy, that is 99.74%. It highlights the potential of transfer learning, specifically hybrid model for enabling precise agriculture. Collaboration between a researcher and agriculture expert is essential for ethical and impactful use of technology. So, for advanced and the effective agricultural need to a automated approach that we present by our CBT hybrid model. Future work. Every work have a limitation and future direction. Same as for us. Real-time deployment. Develop a mobile or edge-based application so farmer can capture jackfruit leaf image in the field and receive instant health and growth stage prediction, and they make decision instantly. Larger and diverse dataset. Expert and diversify the data set across region, season. Jackfruit can attach with it and also diversify the leaches variation. Improve robustness, again different lighting, background and climate condition. Model interpretability. Integrate explainable AI technique to highlight which parts of the leaf image influence the model's decision, improving transparency, trust, and adoption among farmers and experts. This is the references that is the use in our slide from our paper.